I wasn't planning on doing another circular motion video, but I'm kind of on a kick about applying physics to the real world, so we're going to do one over the rotor ride. And the rotor ride is essentially a barrel or drum that you are instructed to lean against the wall, and the drum will rotate around and around, or maybe it will like tilt on its axis and kind of spin you around. Not sure if you lean against the wall, if it's spinning like that, or if you're strapped in, but we're going to keep it simple and just say it stays horizontal. And let's go ahead and peel back the front layer. So we are now looking inside the rotor ride. So we're looking into this barrel or drum. And we have our person who is leaning against the inside as this thing is spinning around. Now, so what the heck is going on here? Well, we need to think of the free body diagram. The person's always going to have gravity pulling down on them. Pretend that's straight down. And the normal force should be perpendicular to the surface, in this case perpendicular to the wall, because at some point in the ride, the floor will actually drop away from the person. So as this thing is spinning, the floor has removed itself from the situation, and these people are now in the air, and that's where the thrill comes in. So the normal force here is what's providing the centripetal force. But what the heck is keeping you from sliding? Well, that would be friction. But how does this all work? Well, here's the thing. The faster you're going, remember your own inertia wants to keep you going in a straight line. So the faster you're going, pretend this is into the page. The faster you're going, the bigger of a circle you'll want to make. So the faster you get going, the more your body gets pressed against to the wall. So for high speeds, this might be the free body diagram. Or sorry, for low speeds, that might be the free body diagram. But for high speeds, this might be the free body diagram. So same amount of weight, maybe. Well, actually, let's draw it over here. So same amount of weight, but the normal force increases. And that keeps you in the circle. The question is, maybe does that static friction force increase? Well, keep in mind that static friction is resistive and restorative. It only applies as much as it needs to. So it can be greater than, it can't be greater than mu times the normal force, but it can be equal to or less than. So even though our normal force has shot up, if our friction force does increase, if it becomes greater than the weight, that would mean that you start accelerating upward, and we know that's not what happens. So even though your normal jumps up, that only affects your maximum static friction. Your friction force that's on you is already locked in. So we can actually increase the speed of the ride, and it will be safer because that'll increase the friction on you, ensuring that you stay put. The lower the speed, the lower the maximum can become, and that's where things get dangerous. So that's the physics behind those rotor rides.